In question 9a, we have two convergent geometric progressions, P and Q, that have the same sum to infinity. The first and second terms of P are 6 and 6 comma R. So for P, the first term is 6 and the second term, so second term is 6R. The first and second terms of Q are, so the first term is 12 and the second term is minus 12R. We have to find the value of the common sum to infinity. Now the formula for sum to infinity is a upon 1 minus r. So r is given by dividing the first term by dividing two consecutive terms. So for p, the common ratio will be 6r upon 6. So the common ratio for p will be equals to r, and for q, the common ratio will be the second term divided by the first term, which will be equals to minus r. Now for forming formulas for sum to infinity for p, so sum to infinity of p will be 6 divided by 1 minus the common ratio, which is r, and the sum to infinity for q will be 12 divided by 1 minus the common ratio. In this case, this is minus r. Now, as they have the same sum to infinity, so we can write the equation as 6 upon 1 minus r is equals to 12 upon 1 plus r. Cross multiplying, we'll get 6 plus 6r is equals to 12 minus 12r. Taking 12r on the left hand side, we'll get 6r plus 12r is equals to 12 minus 6. So 18r will be equals to 6, and the value of r will be equals to 1 upon 3. Once we have the value of r as 1 upon 3, we can find the sum to infinity. So we know that the sum to infinity for p and q is equal, so we can use a formula for p or q, either of these. So we can use 6 upon 1 minus r. So this will become 6 upon 1 minus 1 upon 3, which is equals to 6 minus 2 upon 3. That will become 18 upon 2, which is equals to 9. In part 2, it says that the first term of an arithmetic progression is cos theta and the second term is cos plus sine squared, where theta is from 0 to pi. We have to find the sum of the first 13 terms. The sum of the first 13 terms is given as 52. We have to find the possible values of theta. Now, in an arithmetic progression, if we have two consecutive terms, we can find the common difference by subtracting the two terms. So we know that the first term a is given as cos theta and the second term is given as cos plus sine squared theta. So in the first step, we can find the common difference. So that will become that will be equal to the second term minus the first term. So simplifying this, the common difference will be equals to sine squared theta. Now we know that the sum of the first 13 terms is 52. For an arithmetic progression, the sum is given by n upon 2 into 2a plus n minus 1 into d. Now the sum is 52 for the first 13 terms. So we can write in place of n, we can write 13. 2 multiplied by a, which is cos theta. So we can just write c in place of this. As we are talking about 13 terms, so this will become 13 minus 1, 12. And the common difference is sine squared theta. So cross multiplying 2 into 52. So 2 multiplied by 52 will be 104. And 104 divided by 13. So that will be equals to, so 104 divided by 13, that is equals to 8. So we'll get 8 is equals to 2 cos plus 12 sine squared. Now, as we have to find the value of theta, we can use a substitution. We know that sine squared plus cos squared is equals to 1. So sine squared can be taken as 1 minus cos squared. So we can write this equation as 8 is equals to 2 cos plus 12 into 1 minus cos squared. Simplifying this, we'll get 8 is equals to 2 cos plus 12 minus 12 cos squared. Now taking the 12 cos squared on to make it positive, so this equation will become 12 cos squared minus 2 cos. This is plus 8, and this will become a minus 12 equals to 0. Simplifying this, we'll get 12 cos squared minus 2 cos minus 4 equals to 0. And we can divide this equation by 2 to write it as, so this will become 6 cos squared minus cos minus 2 equals to 0. Factorizing this, we'll get 6 cos squared minus 4 cos plus 3 cos minus 2 equals to 0. Taking 2 cos common, this will become 3 cos minus 2. And taking 1 common over here, we'll get 3 cos minus 2 equals to 0. Simplifying, this will become 3 cos minus 2 and 2 cos plus 1 equals to 0. So cos theta will be equals to 2 upon 3 and cos theta will be equals to minus 1 upon 2. Now, as our value for theta is from 0 to pi in the question, so we can take cos in the positive and the negative quadrants as well. So as the range is from 0 to pi only, which means from 0 to 180. So cos is positive in the first quadrant. So for that, we can take we can find the basic angle. So that will be cos inverse of 2 upon 3. Substituting cos inverse of 2 upon 3 in the calculator. So that will be equals to, so cos inverse of 2 divided by 3, that is equals to 0.8410. So the basic angle is 0.8410. We can make that in the positive quadrant, which is the first quadrant. So this is 0.8410. And now taking cos inverse of half. So cos inverse of 1 upon 2. So that will be equals to 1.04. So this will be 1.047, but we'll make this in the negative quadrant of cos, as cos is negative over here. So this will be 1.047. So the first angle will be 0.8410. So we can write that x will be equals to 0.841 to 3 significant figures. And the second value will be pi minus. So this value will be pi minus 1.047. So pi minus 1.047, that will be equals to 2.0945. So the final answer we can write as x will be equals to 0.841 to 3 significant figures, and the second answer will be 2.09. So these will be the possible values of x.